Hey everyone, welcome back. In this episode, I'm going to be working on the first exercise of homework 3, Hopscotch. So, I am supposed to write a function called skips. There's a type signature. The output is a list of lists. The first list in the output should be the same as the input list. Okay. The second list in the output should contain every second element from the input list, and so on. The nth list in the output should contain every nth element from the input list. So, as we can see here, the first element of the output is the original list, followed by a list containing every second element, so B then D, then a list containing every third element, and finally a list containing every fourth element. So, I think today I'm just going to write a function that will, given a list and an n, return a new list consisting of every nth element from the input list. And later on I'll use this function in my implementation of skips. So here we go. Okay, so I'm first going to get some base cases out of the way. Every 0th element of any list is simply the empty list. Every element of any list is just that list. And finally we arrive at the actual implementation. So I sort of want to keep track of which element I'm on. I did this before in an earlier episode with just a boolean because that function had to perform some operation on every other element of the list. This is sort of a generalization, so instead of using a boolean, I'm going to use an actual integer, and I'll pass around my n, and my integer will count from 1 up to n. Once it reaches n, I know I'm on a multiple of n index in that list, so I cons that onto my output list. And if I'm not on a multiple, if I'm not equal to n, then I just increment the current index or what have you, and don't cons anything onto the output list. So here's what I mean. I'll define a helper function seeded with 1 and n, which is my original n, and x's. Okay, in the case that the current index is equal to n, I'm going to... Oh, and I do need a base case here. Doesn't matter what current or max are, every nth on an empty list is, of course, an empty list. Now I can safely pattern match with the cons constructor. So this is going to be x consed onto every nth. Reset the counter to 1, same n, and tail. Pretty standard recursive function here. Otherwise, I'm just going to recurse. And increment the current counter. Okay, and it compiles. Let's try it out. Try this base case here. Every second element and every fourth. Alright, so it works. I think this function is almost too simple to write a test for. One thing I do want to mention is sometimes people kind of go crazy with this whole lining up of similar lines of code. I think this is a bit overboard, although I do like to line up things as much as possible. And similarly, up here I could have done this. Again, it's a matter of taste, but this is how I would style this particular function. And I know that some people don't like to put spaces around cons, but I think that it's a little nicer with them there. So anyways, that's all. Pretty simple function. Thanks for watching. I'll see you next time.